All right, so we have a function f of x, and we need to factor this, and then we need to solve f of x equals 0. So essentially what this means is we want to put this in linear factors, like, let me do this in a different color, like x plus a number times x minus a number times x minus a number or plus a number. I mean, this could be the plus or minus. And that's what you want to do. And since this is to the power of 4, then there's actually going to be no more than 4 of them. We should be able to account for 4 of these factors. Okay, that's what we're looking for. And then when we want to solve, that's factoring. Then we want to solve for when the function equals 0, well, that means set this whole function equal to 0. That means that each factor can be set equal to 0 by the zero product property. And then when we set each factor equal to 0, then we can find the answer to this. There's going to be 4 answers, at most 4, and those factors will tell you the answers. Now, those answers are sometimes called zeros. So sometimes the question can be find the zeros of this polynomial, or find the zeros of the function, or solve for when f of x equals 0. So let's do that. So to do this, what you want to do, if you didn't have a calculator, we're going to do kind of both. We're going to use a calculator and by hand. But what you want to do is you can find a list of possible rational zeros. You can find a list of all the possible rational numbers that would solve the f of x equals 0 part, or give you the numbers here for the factors. Okay, we can find a list. To find that list, you take the factors of the last number. So we're going to take the factors of 128, and don't worry about the negative. We're going to say plus minus at the end anyways. And then you divide that by all the factors of the front number, the front coefficient. In this case, it's 1. So anything divided by 1 is itself. So essentially, this list of possible rational zeros is going to be the factors of 128, since we're dividing by 1 anyways. All right, now the factors of 128, what would that be? That would be 1 and 128. That'd be 2 and 64. See, 3 doesn't go to it evenly, but 4 would. 4 and 32. 5 doesn't go into 128 evenly, neither does 6 or 7. Now 8 does. 8 goes into it 16 times. 9, 10, 11, 12. None of those numbers go into 128 until you get to 16. So this is basically your list of factors of 128. And we'll put some curly Q brackets and say plus minus. So it looks like there's 1, 2, 3, 4, 5, 6, 7, 8 numbers there, but there's actually all these positive and then all of them negative. So there's actually 16 numbers there, all the positive numbers, and then all those numbers with negative numbers, with negatives in front of them. All right, so positive 1, negative 1, positive 128, negative 128, positive 2, negative 2. All right, so there's a whole list of numbers. Now that's the possible rational zeros. Okay, so let's go to the calculator now and graph it and see if we find any of these numbers as x-intercepts of the graph. An x-intercept is going to be the same thing as a 0, right? It's the value of x that gives you an output of 0, because that's where an x-intercept lives, right? You go left to right and then up or down none. An x-intercept has a y value of 0, so that's the same thing. If you can find an x-intercept, you can find a 0, and if you can find the 0, then you found the answer to this. All right, so let's look at the graph of that. So here's the graph of this. And you'll notice that negative 2 right here. Okay, so negative 2 is one of our zeros. And then over here, 1, 2, 3, 4. I have 4. Okay? Now, the graph of that comes down at negative 2, and then I guess it'll come back up again. And over here at 1, 2, 3, 4, it goes whoop like that. Okay? Now, since the graph, so here we go. We got negative 2 and 4. So that's 2 of our answers for this. Now let's factor it. So what we know so far is we'd have x plus 2 and x minus 4 are two of the factors that go in here. Right here's one of them, and here's the other one. But we still need to account for these other two. So to find the other two, we need to divide the polynomial. We need to divide this whole big polynomial here by the factors of x plus 2 and x minus 4. When we do that, we're going to whittle it down to where it's going to be a quadratic. Let me show you what I mean. And since it's just an x plus 2 and x minus 4, I can use synthetic division. So I'm going to use my 4. Let's use a 4 first. Is a 1, a negative 10, a 24, a 32, and a negative 128. So bring the 1 down, multiply, add. Alright, and then multiply. 4 times negative 6 is negative 24. Then add 0. 4 times 0 is 0. Add 32. 4 times 32 gives you 128. And 128 added together gives me 0. So that 0 right there, the remainder of 0, tells me that my graph is right. That's what it tells me. Alright, now let's go ahead. Now on this answer, use the other division here. Use the division on the answer. This is where a lot of people get tripped up. Oh, we're going to do a negative 2, right? Remember, you got to change the sign there. So let's do a negative 2 on this. So bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. So looky there. I got another 0. Those two values are the zeros. So I proved that those two, graphically, I got those values right at negative 2 and at 4. But now algebraically, I proved that these are also the zeros, and they were part of that possible rational zero list. All right. Now what's left? Well, if I've done my division twice, then that leaves this one down here as an x squared minus 8x plus 16. So I've factored this down to x minus 4 times x plus 2 times x squared minus 8x plus 16. So this is how I factored it so far. Now, this is a quadratic, and we can factor that fairly easily. Alright, the positive here says that these signs have to be the same, and this tells me that they need to be negative, so minus and minus. Numbers that would multiply to give me 16, but would combine together to give me 8, and that would be 4. So notice how I have three of the same factors. So we could write it like this. I have it factored now. I have it factored. I could write it like this. There's 3 of them, right? So I can write it like this. Now remember the graph? Remember the graph of it? Here's a negative 2, and here's 1, 2, 3, 4. Remember the graph just comes down through here, and then it come over here, and it kind of did this little shape. And I guess it comes down through here. Eventually it comes through. So that, if you just zoomed in on this part of it, if you just zoomed in on it, and that's it, that's all you could see, well, it would look like, remember that x cubed, right? That graph x cubed. So just by looking at the graph, I could have known that this was going to repeat 3 times just by looking at the graph, how it looked. All right, I know if it looks like x cubed by itself, then it's actually going to repeat 3 times. And this one just kind of went straight, and that's because it kind of just looks like, plain old y equals x, right? That plain old just straight line business. So looking at the graph, you could have actually figured that out too. But also, that's how we're going to factor it out, is use your synthetic division on what you know from the graph. Those 2 guys were zeros. And then hopefully get it down to a quadratic. And then factor that to get your other 2. Or, you could have done the quadratic formula. You could have done the quadratic formula there too and got the other 2 numbers. You would have got negative 4 as well. So, or 4. You would have got 4 out of this. So we've got our factored. We've answered it by finding our factored form, and then we also answered it by finding our zeros here. What are the zeros? The zeros are at negative 2 4. The multiplicity of 4. 4 has a multiplicity of 3. But it doesn't ask that. It just asks for those zeros, and those are the two answers.